Hello, in this video we're going to take a look on how we can create this asteroid generator in Houdini. So I created an entire fleet from that, not that file exactly, but there is like 4 other variants of it that would create asteroid. This is the Unreal Engine, by the way. I tried making this video as simple as possible and as beginner friendly as possible for you to follow along, but I ended up making this video 30 minutes long, so yeah. And there's actually not that many nodes in the end, there's only few. So let's start by adding a sphere. Before we start by adding a sphere, so since you're very new to Houdini, you need to be in the geometry context, and the way you get to the geometry context, you start from the object context, you create a geometry like this. Okay, now we are in the geometry context. We create a sphere, but we change the primitive type to polygon. Why? Because this is the current one and this is the previous one. Well, you can actually start with that one, but this is more consistent for the result. So polygon, I set this to 20 to increase the resolution. No, not this. Set the frequency to 20 to increase the resolution, and we create convert to VDB. VDB from polygon. And okay, so now we have a VDB. So what is a VDB? VDBs is basically voxels. As you can see, they are voxels. Not sure if you can see clearly, but I can increase this value to 5, and now they are a lot more clear. I'm not sure why they look like pixels, but they are actually voxels. Anyway, so the value I'm gonna work with currently is 0.01. This is a preview value, and the value for export going to be 0.002. We have established that we have a VDB, and VDB are voxel-like things. So now we need to actually remap distance to density. Why? Because the volume VOB we're gonna use, it's going to look for density, and there is a important information here. There is a pound. Not sure why, I can't see. So use no. So we're gonna check fill interior, and we're gonna set this to 20. Well, what's gonna happen if we gonna decrease this? I'm gonna show you later on the video. Basically, this is the bound of the voxels. If this is not big enough, it's gonna be clipping in the model because we're gonna stretch the model bounds. Now we are going to add a volume VDB. VOB. I mean VOB. Volume VOB. Not volume VOB for VDB. The names are a bit confusing sometimes. Well, so instead of doing that, we can check this by unchecking this if you wanna change the surface to density, but this is much better for me and like my preference. So actually I already prepared the VDB volume VOB. Jesus Christ, I already prepared the VDB volume VOB, and we're gonna go through. So we have a volume VOB, and I already have prepared the I did not want to start from scratch and painstakingly create every node. So basically what volume VOB is doing, it's shaping the sphere. We're shaping the sphere here, and we are shaping and adding detail. The first layer, and we have the initial, so it starts out like this. If you want to add a node like turbulence noise, you need to plug the position here, and you need to add an add node, and you need to add it to density so it output the result. This is the basic of density VDB VOB volume. That's a lot of word. Okay, so the first layer is basically shaping the asteroid, and I can disable it and show you. I can disable it. Boom. And this is the first layer. First layer basically shaping the volume, and we have a transform matrix. The transform x is set to 1. This I mean y, the middle one. The frequency is set to 1.2 and offset 2.4 and roughness 0.2. Roughness is adding detail. Turbulence, and the most importantly, the type is Berlin noise, because it can be alligator noise and it can do nothing. Not sure why it's doing nothing. Maybe it's too even. Anyway, Berlin noise. Jesus Christ. Now everything is ruined. Go back to Berlin noise. Berlin noise, I'm not sure if you know what Berlin noise look like, but it's very simple noise. Just to shape it a little bit. Since I mentioned about the volume VDB VOB, well, I mean volume, voxel, VDB, bounds, the bounds of the volume. There is a certain bounds. I will show you like just a second. So for the volume bounds, actually let me show you. So set this to 10. And we need to start increasing the volume of this by increasing the output. So 1.1. Oh, okay. No, actually we need to decrease the output. No, we need to okay. What if I did this? Okay. So basically, now it's very clear. Now it's very clear. So 0.5. You know, like when the model gets out of bound, the voxels, which is the volume voxels, they start to disappear. Did I mention this, that volumes actually, so this is one of the way that you can model organic stuff. Something very organic, if you want to model a rock or something very organic, volumes are crazy good at this. It's procedural modeling, of course. I have a bit of problem with my breathing because I'm a bit sick, so my apology for that. Now, the second layer. So we established the turbulence noise and the fit range, and you just need to press tab or right click and fit range to find it, just like literally the name that I mention it is the actual name of the node. So the second layer, it's adding holes, craters, or holes. So basically what we are doing here, so this is the main setup, and this is it's only warping the texture, this texture. So we can actually, I can show you constant. Actually no, just like this, 1 0. So at 0 the holes are almost perfectly spherical. They are not perfect because the Voronoi texture, Voronoi, I think that's a German name. The Voronoi texture, it's not like the most perfect, but as you can see, this is giving a little bit of imperfection to them. And we have another fit, and we have 1 minus. 1 minus, it can be useless. Like you can make it useless by making this value positive. And so let me go through every one of them so you can see the value. You can pause and see. So this is basically, this is the value. This is a parameter exported, so I can set the value from here. Yeah, so you can see the value of each node. The third layer, I'm adding some cracks, and I'm using Berlin noise with desetting, and I'm fitting it with desetting, fit range, to add some cracks. The fourth layer, it's adding rock details, and I'm using here a very cool trick. Adding, so I have this node to export this value, but the main thing that I'm using here is the divide constant. Divide constant that has the value of 4 and is plugged to the frequency, and this frequency is alligator noise with a roughness of 0.5 and turbulence of 5. Turbulence add layers to the details, and roughness, the more rough, the higher the fine detail of the noise. And mult constant, which is a so mult constant is a multiplier. It's a multiplying with a value. So you can actually add a multiplier, and you can add a value here. You can add a parameter here if you want to export it. But mult constant is basically multiplying with one singular value. And when you multiply like this, I am decreasing the intensity. So for example, I can have it 0.2 to decrease the density. And I'm adding them, basically the math behind this is that I'm adding them to one place, so I can have you're literally adding them. So you're literally adding the effect to here. You can even, if you want, you can plug all these for here, but I like to keep things more organized. I like to keep things more clean and organized. So basically this is a setup. This is the last, I'm not sure if I missed any of them, and this is the first two, and density is plugged to that one, and point is plugged to every single position. Things. Okay, so we established the VDB part of the tutorial. Now we need to convert to polygon. Convert VDB is the answer, and this one we need to set it to polygon. And we have ISO value, which is either curving inward or outward. Like this is curving outward, and like this is curving inward. So, and we have adaptivity. Adaptivity is determining the, if you want the density of the, let me show you, density of the polygon to be mapped more strategically, or more, I don't know, more adaptively. The next thing is this. So here we have, first let me tell you about this. Small parts. This is a lab tool, so sometimes the volume you might have small part. You need to enable this on this node to fix that problem. So now we have the next group, which is also, this is a lab tool called physical ambient occlusion. Let me show you. This is giving an ambient occlusion, and this is giving subdivision, and this is giving displacement, and this is giving color. So I actually forgot about small detail. There is a very important optimization tips you need to worry about, which is file cache. So basically, when you are working with VDB and you when you set this to 0.002 and you want to compute it, after you compute the VDB, you need to plug this, and you need to disable time dependency and keep the version 1, and you need to hit save. So it saves. So basically it saves from disk cache file VDB or VDB cache file, and we need to hit save now. So I'm not going to compute it because it's gonna take some time for me to compute it. It's going to load from this. Now you can actually do this. You can disconnect. I'm just holding Y. You can disconnect, and this is now preventing this block of node to re-execute, because this block of node is process intensive, and it's actually a lot of work on the computer to execute that. So this is a very important for this tutorial. In my main setup, so this is not the final version, but in the final version I have a block of code here, a block of code here. I have so I have one here for the VDB, and I now after that convert to polygon. I have one here and one here, one that goes for the high poly. Wait, no, actually I don't have. No, yeah. Well, actually I only have these two. I have a high-res sub-D, which is subdivision and high resolution one, and I have a low-res one. The low-res block and the high-res one, and I have them plugged into Pake, and then I have a load creator. I have a way to create load, and yeah, that's it. If you want me to do a complete video on this, like an in-depth tutorial to tell you how I made this and set it to Unreal Engine, let me know down the comment section. If you have any question, you can either comment down below, or you can check the description for the Discord server invite, and you can ask me on Discord. So yeah. So subdivision, you just type subdivision, and ambient occlusion, you just type ambient occlusion, lab physical ambient occlusion. Now we have an attribute of this is the equivalent to this, but this work on the geometry, this work on the VDB or volume, this work on the geometry. And now let me show you what is the setup inside. So the exact same principles that we established before exist here. We have a position, we are plugging the position, but we are not adding any position or density here because there is not even a density. So here is a position. You can actually try to add a position to, you can try to do something like this. So basically add, or let me try on a different one. Let me show you attribute Bob. So you can try to do this, and you can add, you can turbulence noise and add this to the position. That will give you very different result from this current setup. This current setup is using a displace along normal, displace along normal, this one, see, no, displace along normal. This is actually acting like a displacement. That one will actually curve the model. That one will do more sculpting, more extreme result. This one is only like you could say this is applying to the surface. That one is applying to the whole model. It's more volumetric. I don't know how to explain it, but I will show you in future tutorials. Tell me down in the comment if you wanna see basic Houdini tutorials. Now, the setup. I'm adding 2 fine noises with this setup. These 2 are giving it the fine noise that I'm going to show you soon. And I'm adding them together, and I'm adding them to a mount. So you need to add it to a mount. I'm controlling, so actually here is the scalar. I'm controlling it from this point. I mean from multi-constant 2 and 3. So the setup here is so you know why I'm using displacement. I'm not adding 2 points. Now the setup here is like this. I'm using turbulent noise, fine noise. It's actually a fine noise with a high frequency and high roughness, and turbulence set to 5, which is like 5. It's like 5 textures overlaid on top of each other. And here is to set to 7 and roughness 0.9, 10, 8, 8. And multi-constant to like dial them down. So here you can actually control how much of these in the scalar, but here I fine-tune them to these numbers. Now I added them and plug them to a mount. You need to plug them to a mount. Now also you need to output to point here. So this is the displacement and this is the color. The color, so show you final results. Final result is a it's very similar to the one from the beginning. Final result. So I want to show you first, before that, I want to show you what each layer is doing. Maybe give it a little bit more detail. Okay, give it more detail too. So I'll actually, okay, so let me just see. And so this is giving the first layer. Instead of having only a solid color as a base, I have a solid color with a, so this one is darker version of the same of, well, no, actually this, so I have a turbulent noise, and like the setup is exact same as before, without, now we don't have a displace along normal, and we don't have a, we are plugging into the CD, which is a color attribute. This is the color. Okay, so first I have a solid color here, and I'm adding noise to it, which is pretty dark. Is it pretty dark? It should be pretty dark, because multiplying by a small number will make it super dark. Yeah, it's super dark. I'm adding this. I think it's only, yeah, it's only brightening the some pixels, or in this case polygon vertices. This is the color applied to the vertices. The more vertices we have, the more color. Anyway, so the second layer of detail is actually, we are adding a color. Is it? No, we're not adding a color here. We're adding a noise, and we are adding the same one. Oh, okay. We're adding a darker version. We're adding a darker version with a mask. This is the mask, and this is the darker version. Now here we are adding a lighter version with the ambient occlusion. So the ambient occlusion, what I did here, I did the output attribute to AO mask, and here I added a bind just to, so bind export, because to export an attribute, bind is to import an attribute, or if the attribute appeared here like CD or point or V or force or N is normal, V is points, and CD, as I said, is color, and UV is UV. So what I'm doing here, so before I continue on, let me show you. So this is the, not sure why it's too dark, but it is too dark. I have the ambient occlusion value, I have it mapped. So this is ramp parameter, just so you know, and this is the parameter because it's a parameter, so it exports the parameter into the parameter. It's called, this is, I'm just getting the information, the exact, wait, so basically it's called parameter interface. Yeah, so this is called the parameter interface, and so it exported from here. This is not the real deal. The real deal exported to intensive, so I'm multiplying it to, then I'm fitting it to get a very specific value. So this is by default 1, the output, this is in min, in max, out min, out max. Tell me down in the comment if you want me to make more extensive video on this project and on this node too, if you want like a larger video. So anyway, so basically this is what this is doing. It's giving the light range a much bigger range. So now we are plugging it into a color mix to get to, so let me show you. So what this is doing, so the details, these details are added here. You can have them in one node, but I like to organize it this way. Even the volume bulb, I have it in my original file organized in a different node. Anyway, so this one is adding these details and this one is adding the color. And as you can see, the color, so these white spots we added in the end from the ambient occlusion, and they are layered on top of the old layers of darker spots and noises. So I hope you enjoyed this tutorial. Tell me down in the comment if you find it easy and achievable for you. Tell me down in the comment how much do you find Houdini easy or difficult. I would love to make more Houdini tutorials. And so for the file, I want to clean it up before releasing it, so tell me down in the comment you want the file so I remember to release it. So this is been the Polygon Academy. Thank you for watching and